So if you're going to be a good wireless engineer, you need to be able to use all of the tools at your disposal to create and validate good wireless designs. That way, whenever it comes to deploying the design that you've created, you know that you have accurately designed for the requirements and you are good enough at using your tool that what you predict and what you design is validated in the real world. So what I noticed as coming from a wireless technician background into a wireless engineer is that there's not a whole lot of free content available for learning wireless design tools like Ekahau or Hamina. There's bits and pieces out there, but I wanted to create an all-in, in-depth video from the ground up, as if you have never used a wireless design platform before, you've never used Hamina before, so that you can feel comfortable using the platform and using it for your wireless designs. With that being said, in this video, we're going to work from the ground up. We're going to assume that you know nothing about the design platform and that you don't even know how to import floor plans. So we're going to start out importing your floor plan, setting scale. From there, we're going to draw our walls, draw our in and out of scope zone, place our APs, edit our channel configuration, everything that you need to do to get a wireless design created and ready for either your company or your customers. And then we're going to look at some edge cases like designing for sloped floors in an arena and designing for wireless point-to-point links. All of that's going to be covered in this video, and hopefully you'll walk away from this video feeling much more comfortable using Hamina and designing wireless. So let's jump right into Hamina and get started on creating our wireless design. To start with Hamina, everything is done based off of projects, and then inside of projects you have different floors. Start a new project, and I'm going to name this one Hamina Cores. Then you can select which country it's in, which can affect some of your regulatory requirements, or what type of setting you're in. So in this one, I don't think there is one for school. There's one for university, college, school. So I'm going to set my environment as school, and then I can set the different project folders here. I'm going to hit save. Now I have my project created, and now I need to add a floor plan. I can either do that up here on the top left, or I can do that here and drag and drop a file. So I just click on my drag and drop floor plan here, and I'll select the school floor plan and hit open. Then it'll take it a second to process. And you can do more than just picture files here. So this one is just a PNG of a floor plan of a school. You could do something like straight out like CADs directly in here that have the actual walls already marked. So instead of doing something like this where you have to manually draw your walls, you could upload a CAD and then it already has the walls drawn for you, and you just have to select what kind of material type they are. In this one, we don't have that luxury. And you'll notice I've got my floor plan here in the bottom right. What we're missing right now is scale. So ideally, whenever you have a floor plan given to you, it already has scale set. But in this case, I don't have scale. The best thing to do would either have someone on site measure a wall, or you go out on site and measure a wall. But in this case, I'm just going to fib it just because it's this course, and I'm going to say from here to here. So whenever I click add scale, it's going to give me this ruler from here to here, and I'm going to call that 15 feet. The longer the wall that you measure, the better, because if you're off by a couple of pixels here or there, it can drastically change what the floor plan is like throughout the design. So I'm going to hit set, and now I still have my scale tool here, so I can go through, measure the length of the full wall, and that's this tool over here on the left. So the next thing to do after you set your scale is to set your in and out of scope zones. So this is going to be the area, if I click on this tool on the left, this is going to be the area where you want to design wireless for. And you just draw an outline of your building. This is going to take a minute, so I'll skip through this real quick. So, and now I've drawn all the way around my floor plan. You can see I've connected these last walls, but my tool is still active. What you do after you're finished drawing walls and you want to say that you're done with this is just right click. And after you right click, you have the option either set the area that you just drew. So I drew around this floor plan. I can say this is my in scope zone, or I can do an out of scope zone, and you can layer these. So if you were designing for this building, but specifically not for the courtyard or not for the bathrooms, I could draw a box around these bathrooms and put out of scope zone because I don't care for that. So I'll go back to edit, and now you notice that this area outside is kind of grayed out. If I wanted to, say, draw this corner a little bit better, since I drew it while I was zoomed out, you can zoom in and click Control and your scroll wheel to zoom in and out. And then as you're zoomed in, if you want to go and move around this floor plan, you can just click your spacebar, hold in your spacebar and move your mouse, and that's going to let you navigate around the floor plan. So you can be more detailed in the way that you draw this. So I drew this kind of bad. I can be more detailed. I can also move these lines after the fact, so I can click here on these squares and move those lines in a little bit better so that it matches this curve just a little bit better. If I wanted to draw an out of scope zone, like for this bathroom, I'm going to draw a square around it, right click, and put that as out of scope. So now I'm designing for this building, but not for the bathrooms. Maybe I don't want to design for the elevators because we don't expect wireless signal to do well inside elevator shafts. And I'm not putting access points in the bathrooms anyway, so I'm not too concerned about the coverage there. So now that I have my in and out of scope zones, I know what I'm designing the wireless for. I've got my map scaled. The next thing that you're going to want to do is draw your walls. Like I said before, if you have a CAD, it makes this a lot easier because all of your walls are already drawn for you. You can select what kind of material they are. So I'm going to do this the long and manual way, where I'm going to click draw walls, and then I can choose the different material that I want to use. In this instance, I'm going to just use heavy drywall. So I can click through here and select my different material types. And by default, they show you the height of the object and the material. So in this instance, I have drywall. It goes from floor to ceiling, and it is 4 decibels of attenuation. If I wanted to change this value for whatever reason, I can click add or modify, and I can change all the different values for this material. So I can say how tall it is, what kind of material it's made out of, and the attenuation. So if I wanted to change the attenuation for that, I can do that in here. And change things like the color. I can add a whole new wall type if I wanted to, and have a custom material here. So if it's something specialized, like it's concrete, but it also has steel plating in between it for whatever reason, or I've had customers where it was drywall over brick and its attenuation is basically brick plus drywall because the building was renovated, and there's not a value for that here in Hamina. So you could go out on site, measure the material yourself with an AP on a stick, and then come back in here and add a custom material that says walls for this building or walls for this customer, and give it an attenuation value. I'm going to hit cancel out of there. And now I want to go ahead and draw my walls around this building. So maybe the exterior walls are concrete. So I'll go ahead and make those that. So let's just say let's just draw the exterior walls first. And what I'm going to do here is I'm going to hit Control, and I'm going to zoom in further using my space bar to drag myself along through this design because I want to get really accurate with this wall for whatever reason. Makes it way easier to do it if you're zoomed in, and then after I'm done, I'll just scroll back out and continue drawing these exterior walls. And then after I'm done drawing these exterior walls, I can just right click again, and that'll cancel out my selection for that wall. So all of my exterior walls are drawn, and now maybe my interior walls are drywall. So I'm going to do that, but I'm going to skip over all of these doors because my doors are going to be a different material. So now I have my interior drywall done. Now I need to do my elevators. So I'm going to go ahead and do that for these. And there's actually two ways to do an elevator. You can either do it by drawing a wall, which you'd be drawing a box around the elevator, or you can do it as an attenuating object and do it here. So an attenuating object, instead of just drawing walls, you can see it fills in this area. And even though I have this as an excluded zone in my design, it's still very important that I place the elevator here, because say I place an access point right here. And if I have this as an excluded zone, but I don't have an elevator placed here like there will be in real life, Hamina is still going to send the signal from this AP through this area here. So if it's placed like right here in this corner, and you're still going to see signal from the AP over here in the corner. So just real quick to show you what that would look like, let me take an extreme AP and I'm going to place it right here. So in this corner, so you see where it is now, even though this is an excluded area, right? So it's not showing any signal right there. But I've taken and moved that elevator away, instantly you see a difference. So put that back and boom, huge difference there. Same thing if I place the AP over here in this area. So right here I have this AP placed and I have elevators here and a great signal going through here. But I still need to place this object here. And I'll go ahead and scale it out so it's the actual size. I still need to place that object there because you see how different the attenuation values are now that I have it there. So even though it's not an included area, it's still making a huge difference, because even though you say that's not an area that I want to design wireless for, the predictive models are still going to send signal through here and show on this design. So let me go ahead and finish placing these objects. I'm going to copy. You can Control C and Control V and copy objects and walls. So let me place that elevator back here. I'm going to delete this AP just so it's not causing any visual noise as you're watching this. So the next thing we want to do is draw our doors. So I'm going to say I have wooden doors or metal doors. I'm just going to go with wooden in this case, and all I have to do is connect these areas here. This is going to take a minute, so I'll skip through this. Something here to be careful for whenever you're doing these designs, you can see that I drew this wall or this door here for these double doors, and I missed a section here. Hamina is going to show signal coming out of here a lot stronger this direction than it does through the wall or through the door. So I need to make sure that I'm connecting all of these gaps. And now I'm done drawing my walls for both my exterior walls, my interior walls. I've drawn attenuating objects for my elevators, and I've drawn my doors. Something else I could do is for these stairways, I could draw an attenuating object here, depending on if the stairway is going up or if it's going down. Looks like this one is going down, that one's going down as well. So I could do that. And if I wanted to validate what the design looks like now, I can go through and click this icon in the top right, where I go from 2D to 3D. And this will just validate and show me all of my different walls and objects that I've drawn here. So you can see my elevator shaft here. My doors are going to a certain height. I think it had it at 7 feet. And then it's drywall above my door. That's really important. You don't want to measure a door floor to ceiling. You want to measure it as it would be in real life. So now I have this really cool 3D model. And a lot of customers really like to see this. Your stakeholders might really like to see this, that you're being so accurate in your design that you can show them a 3D model. And I can just right click as I'm scrolling through here and go around the model. I can't select attenuating objects from here. And then I can scroll up and down to move up and down from it, or I can click the zoom here to zoom in, or change the direction this way. I'm going to go back into the 2D section now. And the next thing you could do is draw a capacity zone. So this would be how many devices you expect in a certain area. I'll do this from the tool on the left-hand side, capacity. And when I'm done, I just right click. I can go back in and select the wall of that capacity zone just to change the devices here. So you can add different devices from here, whether it's an Android phone, an iPad, cellular, whatever it might be, and the number of those devices. So if you're just expecting Androids and iPhones, you can do that here and say I expect 25 Android phones and 25 iPhones. For this section, it's going to do that here. This comes in handy whenever I actually start placing APs. I can see how many devices are going to be associated to a specific access point. After you've done your floor plan designs and everything is ready to go, we'll click here on the left-hand side, click on our access points, and this is where we can choose what model of access point and how they're mounted. So in this example, I can click from this drop down and I can select access points from pretty much every vendor. And then after you select the vendor, then you'll select the specific model. So if I'm doing an AP3000 or something like an AP4000, I can select that from here. And then how they're mounted, ceiling, wall, pole, floor, because this is going to drastically change the design and how the RF coverage looks like depending on how the AP is mounted. So in this instance, I'm going to do ceiling mounted. We're going to pretend this is a drop ceiling like most schools are. And we're going to do 8.2 feet. And from here, we can even get pretty granular with the access point name and the different settings for it. I'm going to go ahead and place an AP in this laboratory. And I can click directly on this access point if I want to change any of its specific properties or give it a different name. What you'll see is by default, it has all these different configurations for the various radios on the device. I'm only focusing on 2.45 and 6 gigahertz. If I wanted to change the transmission power of the AP, I could do that here. And I could change this up to 15 or 16 or whatever I wanted it to be. But be cautious of what your management platform allows. Not every management platform or AP lets you go above 20 decibels. I know in the Extreme platform, 20 is the max. Some platforms let you change this value a little bit higher. It just really depends on the vendor and the model of AP. So I'm going to do 10 for 5, 12 for 6. And then if I needed to change something like my channel settings for my APs, because auto channel assignment is enabled by default in Hamina. That means once I place several APs on the map, Hamina is going to choose the best channels for those APs. I can change that setting here if I just click directly on these channel settings. And I can choose my 2.4 gigahertz coverage, disable unnecessary 2.4 gigahertz radios because we only have 3 channels. I can choose my channel width. Maybe there's specific channels that I'm trying to avoid in 5 gigahertz. I can deselect problematic channels. And then maybe I want to change my channel width in 60 to be 40 or 80. Or if I want to do an automatic channel width. I'm going to go ahead and hit save here. If I wanted to change my auto channel assignment, I can do that here. And then I'm just going to click save. And then let's place some more access points on the map. So I can just reselect that tool and go through and place my APs where I need them. And then as I'm doing this, the same thing as before, I can click my space bar to drag around, click control and zoom in and out. and we'll place our APs there. You'll notice that as I've placed them, there's no coverage in the bathrooms, in the elevators, because I select that as a out of scope zone. What that means is it's not going to model the wireless for there because I'm claiming that area as out of the scope of this project. So after I've done all of that, I can click on any specific AP and see its various settings here. I have everything configured the same, but you can see which channel assignment down below that these APs are getting. And you can even see on the right, 2.4 gigahertz for this specific AP is off. As I click into each one, I can see where their coverage is at for 5 gigahertz. If I wanted to view other settings other than 5, I can click up here under this Wi-Fi uplink coverage, and then I can change what the heat map is showing me. So if I wanted to see secondary coverage, I can do that here, or tertiary. Or if I wanted to see coverage in the downlink versus the uplink, signal to noise ratio, data rate, interference, all of those. And then if I wanted to see specifically 6 gigahertz or specifically 2.4, all of that. We're gonna focus back on 5 gigahertz. Whenever I'm in this map view for my APs, I can see the various different settings for the AP. So this is the 2.4 gigahertz radio, these numbers are the 5, and this is the 6. And what this is showing me is the 2.4 gigahertz radio is off, and it has 0 clients because it's off. The 5 gigahertz radio is on channel 149, and it has 29 clients. And the 6 gigahertz radio is on 149, and it has 12 clients. Here on the bottom, I can see my radio distribution, how many radios are on in 2.4, 5, and 6. I can click into my clients and see my client distribution. So I can say I have this many 6 gig, this many 5, and this many 2.4 gigahertz clients. So if I actually click on this box here at the bottom, it's going to bring up this capacity requirements. And this is where I can toggle on if I have 6 gigahertz capable clients, about how many I expect to have, and my max number of clients per radio. So this would determine what kind of capacity I'm expecting for this design. So I'm going to go ahead and click out of there. And then you can also see all of those at the bottom. To the left of this setting, I have my Wi-Fi uplink coverage for 5 gigahertz. If I click into here, I go to the settings for this. And this basically tells me what area of the map is going to be what color depending on the signal strength. So right now, anything above neg 65 is going to be green. And anything above neg 70 is going to be yellow, and then these varying shades in between. I can change my expected client height and the opacity of the heat map. So if I wanted to change that down so that it's less green or more green, depending on the coverage, I can do that. And then if I wanted to change any of these values, I can do that here. So maybe neg 65 is not my requirement and it's actually neg 67 or neg 70, I can change those values here and you'll see that reflected. And then if I hover over this box here, you can see where it says 99% of my coverage is high and 1% is decent, nothing is lower edge. Whenever I'm viewing this map, if I want to change what is displayed, I can do that from this icon here on the right. I can change whether I want to see my channels or my EP numbers or any number of things. If I want to toggle off my walls for whatever reason, it's still going to calculate the values of those walls, you just won't be able to see them. The next thing you can do is add network infrastructure if you want to. If you know exactly where your closet is at, you could place it on the map. I'm going to go ahead and place a switch here. And by default, you see the expected cable runs to this switch. And I can change the total ports. Maybe this is a 48 port switch and I have a PoE budget of 700 watts. I can do that here and I can calculate now my port usage and my PoE budget and expected cable runs. Granted, not all of these are perfect. So now I can see my port usage and my total power budget for this switch. 48 ports is what I selected here, and then 700 watts. And then if I place a second switch, maybe there's 2 closets in this building, and we're gonna pretend that we have it at the classroom. Then it's going to show me the closest switch for each access point. So it's saying, hey, this music room AP should be run to this classroom switch, and then everything else over here is going to be run to this switch. So it just depends on where they're at on the map or what gets run to it. So as I drag this around, you can see the different connections lighting up as they are closer to the switch. So it doesn't make sense to run this classroom AP all the way to this switch because you'll have a shorter cable run if you run it to this switch. Granted, this always depends on what it's like in real life and where the cable trays are and where the closets are at. If I click on this power and cabling details for each switch, it's going to show all of the APs that are ran to it and the expected cable length, and then the PoE load, and then the total cable length here that you'll need for this project. But obviously it says plus or minus 20% because it's hard to be exactly accurate without knowing where all the cable trays are going to be at or where the cables can be ran. We can also drop in specific clients. So if I needed to show where cameras are at, I can do that here, and it will do the same thing as the access points and show their cable run, and then this is going to show up on the AP's report as well. And it's going to show the power budget. So if I click back into this switch after placing a couple cameras, you can see their cable runs are going to be to that switch. I can also see that there are cameras and how much watts they consume and their cable length for the switch. It updates this cable length value and the PoE budget of the switch. So not only can I do my wireless designs in here, I can do my wired designs as well. So the next thing I can do is go into my client view, and this is going to show me the expected roaming behavior and connection behavior of different clients. So in this example, whenever I clicked on client view, it brought up this little guy here, and I can select the different clients that I want it to be. So if I want it to be an Android phone instead of an iPhone, if I want it to be 6 gigahertz capable or not, and then show the association area. So show the area of association for that client, and then which link direction I want to see. And as I drag this client around, it's going to show me what band it's on, what AP it's connected to, so it's coverage, so neg 56 dB, really high data rate, and any interference it sees, and then the band and the MCS rate. So this is a 2 spatial stream client at 40 megahertz. So as I drag this client around the map, I'm going to see the different APs that it roams to. So if I go into this room, I can see, man, this client's really not roaming to that AP because the signal to this AP is still so good. So maybe I need to change my power values so that I can actually get clients to roam to the AP in the room that they're in, because this client's not looking to roam at neg 61. But if I get closer, and now I'm getting closer to this AP, now it finally roams. And then I go into this room, and I can see that client's not looking to roam yet, even all the way back here. So I really need to change my power in this building because I'm really seeing some sticky client as a potential issue as I'm going through the building. A cool little Easter egg here is while you have this guy out, if you press W on the keyboard, he turns into a walrus. Yeah, I can just click W again if I want that away. If I want to get out of this screen, I can just hit edit again. It's going to take me out of there. I can also add notes to this design. So if I want to add a specific note for a specific room, I can do that here. Change the different color. I can put something in here and put HVAC on ceiling. Maybe there's ventilation or something up there. AP may swing plus or minus 10 feet. So I could say there's HVAC in this building, in this area, if the AP might need to swing this way or that way, just as a note. And then I can even add pictures to it. So if I had pictures of the installation point, I could add that here. The next thing we'll do, now that we have our beautiful design created, we have all of our APs placed, we have some switches, we have our cameras, is now we need to generate a report. This report is going to be used either by the stakeholders in the project. Maybe your manager needs to determine that your design is good, or you have an internal review. You can generate a report and send that out to your team that shows the coverage of all the APs, where all the switches are at, the expected camera locations, all of that to report towards your team. And you can even do something like generate a report that's meant for your installers so they know where all the APs go, but they don't need the coverage maps. They just need to know where the APs need to be placed. So if I want to do that, I'm going to jump in here, click this report icon, and create a new report. And I'm going to give this a report name of Hamina training. And I can use a template from other designs, other reports that I've made. So if I've created a report and I really like the template of that report, I can select that from here, but I'm going to create a new one. And now I get all of these different options on the left-hand side of the items I want in the report. So my bill of materials, my notes and zones, AP placement, all of that. For this design, I didn't do any design for BLE. So I'm going to click the little eye icon next to BLE so that this doesn't show up in my report. Otherwise, it's going to be pages of unnecessary information because I'm not designing for BLE. And in this report, maybe this is going to be an internal review of everything in the design. So I'm going to keep everything here because maybe my team and I, we want to know everything about the design. We want to review all of it. I'm going to leave that in. I can add a logo up here if I want to give a specific logo as part of the report. It'll just show up at the top of the pages. So in this instance, I have my bill of materials here. I can change the description, the title or the description of each element. And now I'm going to hit this generate PDF in the right-hand side. So if I click that, I'm going to hit generate PDF here, and it's going to appear in the right-hand side, generate the PDF with all of this different information on it. So my AP placement, coverage, SNR, all of that. And this is going to take a minute. This is cloud hosted. So since Hamina is cloud hosted, it generates a lot faster than maybe an on-system application. We'd call that a FAT application, depending on the hardware used. Obviously, if you have some old laptop that your company provides, it's going to generate a lot slower if you're using one on-prem. But this one's cloud hosted, so it just depends on the other end of the connection, Hamina servers generating that report for you. So I'll skip through this instance because it can take a minute. So that took about 6 or 7 minutes to complete. I can click up here again. So after it's finished, I can click that same icon again to download it. And I can either choose to regenerate or download it. So that'll come up here. And now let's look through the kind of information that I have for this. So here's the title slide of Hamina training made by me and the date. And then it gives you this table of contents. So bill of materials, notes and zones, everything in order as we had it selected before. All of the different APs. So now we have our bill of materials. We know how many APs to order and how much cabling we need. It'll go into our different notes. So you can show this notes number 1, here on the left number 1, and HVAC on ceiling AP may swing plus or minus 10 feet. And then as I scroll through, this is kind of the information that you would give to your installers. So they don't need the heat map, they just need this single page. I can generate a PDF with just this one page or use like a PDF editor to split this off and hand it over to the installers. Maybe give them this one and then give them the one with the notes. And then I'll go through my varying coverage. So 2.4, 5, and 6, that's all primary coverage. And then we're going into our secondary coverage for 2.4, 5, and 6. And then even in our tertiary coverage, and then into our signal to noise ratio. So then it even shows on the bottom what our little legend is for high, decent, and low. And then our interference for 2.4, 5, and 6. It's great if this is empty. So nothing here, a little dirty here, and you can see how many interferes at the bottom. And then into our data rates, and then our AP list and their exact mounting height, expected PoE draw, and cable length per AP. So after that, you can see our different radio details. So for each AP, the transmission power of each radio on the AP and the channel width. So this is really important for whenever you actually go to configure the management platform for these APs, because you want your design to match reality. So you want to make sure you're using the same settings on the management platform as you're using in the design platform. And then for our network equipment, we can see the varying different cable runs, the expected switch locations, specifically for wired devices. So for our cameras, our APs are off this list. And then the switches, expected client count, total port count, PoE draw, and power budgets. So you might hand this page to installers, this page to installers, and just so they know where each AP is expected to run and where the switching closet locations are at. If I wanted to change this report, I would have to go through here and say maybe this time I don't want project notes or notes and zones, and maybe we don't care about the client view or the radio details or whatever. I would have to click the different items I don't want, and then I would have to regenerate the PDF here and then download it again. But originally it took 6 or 7 minutes for it to generate this PDF, so it's not a whole lot of time that you're losing if you need to change anything in here. Or you can always generate everything and then take a PDF editor and pick what you want. So now let's go into some bonus content. Say I'm designing Wi-Fi coverage for a stadium, and instead of a flat floor plan, I now have seating that goes kind of down at an angle. It's like at a slope. I'll go into my school floor plan here, click here, and I'm just going to add a new floor, and I'm going to upload a floor plan for a stadium. So now that that's uploaded, you can click and jump over here for the seating map. And these are not in a perfectly flat area. So in this, looks like a hockey rink, these are not completely flat. So if I design wireless like this, normally I'm not accounting for the attenuation of the slope or the attenuation of any fans in the stadium. So let me go ahead and set my scale real quick. And I'm going to set this, and we're just going to say this is 50 feet. And I'm going to click this multi-floor icon here, and I'm going to click sloped floors. Out on the right-hand side, you'll see the lower height. So this will be the bottom floor of the slope, and the upper height, so how tall it is in the back. So I'm going to draw for this little section over here, and we're going to say row A is the floor. And I'm going to draw the bottom side and then go up the slope here and then draw the top. And then whenever I'm done, I'm going to hit right click. And then if I go into the 3D space, you're going to see that this looks very different now. And instead of just a flat floor plan, now I have this slope here. And this is going to be really good for designing for a stadium like this, because now I'm accurately accounting for the slope of this angle. Something else I can do whenever I jump back into the 2D version is if I click edit and then click on this slope, I can hit include crowd in the attenuation. I can choose how tall the crowd is and the crowd height. So I can choose whether I expect everyone to be sitting or standing, depending on the crowd height. And then if I go back into 3D, it's going to add this yellow section here, and that's going to show where the crowd is at on this slope. And then I can change the different attenuation values of the slope and of the crowd. And then maybe I wanted to add an attenuating object, such as, I'm not going to do that. So that would be the way that you would do something for a stadium. And if I wanted to expand this out, another slope here and connect it in, I can click that, go back into 3D, and now I have the slope for this section here. And I would go through and do that for the rest of it. Obviously, you need to have accurate measurements of the height of these stands versus what I'm doing where I'm just guessing. But that's how you would do it for a stadium design like this. So now let's look at if we wanted to build a point-to-point. So I'm going to add a new floor plan here, and I'm going to do it of this Google Earth image. Say we wanted to do a point-to-point from this building to this parking lot. And a tip here whenever you're designing point-to-points is if you're using Google Earth, you can just right-click, hit measure distance on both ends, and then you have a really good, accurate measurement here. So I'm going to go ahead and hit scale, and I know from here to here is 100 feet. And now I want to design a point-to-point from this building to maybe there is a pole out here in the parking lot, and I'm going to do mesh coverage from here. So what I can do is click on access points and let me find one that would be good for a point-to-point link. And I'm going to do this 460C. It has a sector antenna, and I'm going to place it here, point it this way, and then I'm going to place another one here and point it this way. And now I need to change the mounting height. These aren't going to be mounted at 3 feet in the air. They might be mounted something like 15 feet in the air. I'm going to do that for both. And I can change the down tilt or the uplink. So here's something for whenever you're using something with a directional antenna. With this access point, if I click here on the AP, I get this little pointer. That's the directionality of the antenna. So you can change where it's pointing. So since it's the point to point, I want to point these at each other. And then I can change the configuration here for the channels and even the down tilt or up tilt of the antenna. So if I wanted to change the transmit power of the AP, I can do that here. Say if I wanted this at 20 decibels and then this one at 20, and then I can even change the channel settings. So same thing as before, changing the channel settings, but if I click into this access point, I'm going to change its connection from Ethernet to mesh. And then when I do that, it's going to auto select the mesh AP, and then it's going to set which radio of this AP. So since this is just a 2.4 and 5 gigahertz AP, it's going to automatically select the 5 gigahertz. And now whenever I click on this link, I can see the uplink and downlink data rate. So this for spatial streams on 5 gigahertz, I can see my uplink and downlink here for this mesh. If I wanted to change this to be an AP with like an external antenna instead, so maybe this 3000X, I can change what kind of antenna is on this device. So if I wanted something that might work better for a point-to-point link, I'm going to want a very directional antenna. So we'll just go through here and select, and it's always good, even though you're getting these designs for this antenna, it's always good to get it from the manufacturer as well. So I'm going to select this Exceltex antenna, and I'm going to say this one's an AP 3000X as well. And I'm going to choose that same Exceltex antenna. And then I have to select this one again to connected by mesh, and then it's going to form that mesh link again. So you can change the different antenna types, you can change how they're mounted for these, and then same thing goes with their transmit powers. If I wanted to change that to 16, not to 16, I can do that here. And then I can see my signal quality change. It's just a 2 spatial stream one, but you can choose these different antennas here. And then you can also change the band, and then you can zoom around this model. You can download this if you want to. It's going to download as an OBJ. But that would be how you would design for a mesh network in Hamina as well. So if you have a point-to-point or a mesh that you want to do, you can do that within this platform as well, and then generate the same reports as before. So now that you have watched this video, you now have all the tools you need to create awesome wireless designs. Whether that's creating the wireless design or even doing a wired infrastructure design, depending on where devices are placed in the environment. All of that into generating your reports for either your team reviews or for your installers. And we even went over some of those edge cases where if you're designing for a sports venue that has sloped floors, or if you're designing for an outdoor point-to-point link. So I hope now that after watching this video, you're much more comfortable in using Hamina or any wireless design platform, because most of them are very similar. So if you could take some of this information that you know from here and bring it into Ekahau, and while the buttons might be different and the look and feel of the platform might be different, you now have a foundation that you can use to take with you to any of those other platforms in order to create great wireless designs. So I really appreciate you watching the video. I know this one was a long one, and we covered a lot of information, but I hope this was able to help give you that foundation to feel comfortable with those tools.